In August of 2024, a machine floating 1,000,000 miles from Earth turned toward the nearest star like our Sun, slid a mask across its blinding face, and stared into the dark right beside it. And something was there, a single point of light, 10,000 times fainter than the star, sitting in the narrow warm band where a world could hold liquid water. For one image, it looked like the answer to the oldest question we have. The nearest possible world around the nearest possible sun. Then they looked again. It was gone. They looked a third time. Still gone, one point of light seen once, in a single frame that has refused to come back. We do not know if it is a planet. We do not know if it is dust. We do not know if it was ever there at all. And we have already given it a name. That number, 10,000 times fainter, means nothing until you hear the other number. Across the galaxy, we have found and confirmed more than 6,000 planets around other stars. Around the two sun-like stars next door, 4 light years away, the closest copies of our own sun in existence, the number we have confirmed is 0, not 1. We can weigh worlds, circling stars so distant, their light left them before there were cities on Earth, and we cannot tell you whether a single planet orbits the star closest to home. You have spent your whole life believing that the closest things are the easiest to see. Hold something in your hand and you can study it. The house at the end of your street. You know better than a tower across the city. For stars, that rule runs backwards, and the nearest sun is about to prove it in a way that does not stay out there at 4 light years. It turns around and points at us. So tonight there are 3 things hanging in the dark, and we are going to chase all 3. A dot that appears and vanishes around the nearest sun. A dim little runt of a star, the least likely member of that whole system, that somehow has worlds when its 2 bright siblings have none. And one quiet question underneath both of them, the one that should follow you out of this. If we cannot see what circles the nearest sun, could anyone anywhere ever have seen us? This is not a story about something hiding. There is nothing hiding. There is something sitting in the open that the most powerful eye humanity has ever built, stared straight at, and could not hold. This is not a guess. This is the measurement. Before we begin, if you are kind enough, a gentle like and tap on subscribe would mean the world to me. It is a small gesture, but I hold it with deep gratitude because every bit of your support keeps this tiny universe alive. Let us begin. Start with the cruel joke buried in this system because it is the fastest way into how strange the place really is. There are 3 stars at Alpha Centauri, not 1. Most people picture a single point of light sitting alone, and that picture is wrong from the first glance. 2 of the 3 are bright and sun-like. The larger Alpha Centauri A is almost a twin of our own sun, the same yellow colour, just slightly bigger and brighter, burning the same fuel at roughly the same point in its long life. Its companion, Alpha Centauri B, is a little smaller and a little cooler, an orange cousin. The 2 of them are bound together in a slow gravitational waltz, drawing close and pulling apart, swinging from about the distance between our Sun and Saturn, at their nearest to about the distance between our Sun and Pluto, at their farthest, around and around on a clock that turns once in roughly 80 years. A single human life is about long enough to watch them complete one circle of each other. And then, far out beyond the bright pair, there is a third, a dim red ember called Proxima, so faint you could not see it with your eyes, even though it is the single closest star to our sun in all the sky. It is the runt of the family, hanging so distant from its 2 siblings that it sits thousands of times farther from them than the Earth sits from our sun. A single trip around the pair takes Proxima more than 500,000 years. It was already on that lap when our species looked nothing like it does now, and it will not finish before our species is gone. 3 suns loosely chained across an enormous gulf, 4 light years from your window. And it is worth being honest about what 4 light years means, because the phrase slides by far too easily. It is about 25 trillion miles. The light leaving those stars tonight, racing at the 1 speed, nothing in the universe can beat, will not reach your eyes until you are more than 4 years older. The fastest object human beings have ever flung out of the solar system, a probe now drifting through interstellar space, would need something like 70,000 years to cross that gap, longer than our species has had farming, or art, or written words. And yet, out of the hundreds of billions of stars in our galaxy, this is the near one, the next door neighbour, the closest other sun there is. Everything else is farther, most of it unimaginably farther, the bulk of the galaxy so distant that the light arriving from it now left before there were people to wonder about it. Hold those two facts together and feel how they grind against each other. 4 light years is a wall we may never cross in person, and it is the smallest such wall in the entire sky. Now the joke. The 2 bright stars, the ones that look like home, the ones every dream of leaving Earth has aimed at, have given us nothing, and the dim runt has given us worlds. Proxima has planets. We have actually found them, and we know exactly when and how. In January of 2016, a team of astronomers launched a campaign with a name as wistful as its target, the pale red dot, and aimed their instruments at the little star night after night, watching for the faint regular tug of something unseen. Led by an astronomer named Guillaume Anglada Escudé, more than 30 scientists scattered around the world watched the signal climb out of the data. About 20 nights in, he began to let himself believe it. 10 nights after that, he started writing the paper. On the 24th of August that year, they announced it in the journal Nature. Proxima b, roughly the mass of Earth, almost certainly rocky, circling its little star once every 11 days, sitting in the habitable zone, the band where a world could be warm enough to keep liquid water on its surface. The nearest planet to Earth outside our own system, around the closest star there is. There is a second one too, confirmed in 2022 and called Proxima d, lighter than almost any world we have ever detected around another star, a featherweight that races around the star in only 5 days. A third candidate was announced, and then fell into doubt, and most astronomers now think it was a ghost in the data, rather than a world. But 2 of them are real, confirmed, weighed and counted. The least promising star in the entire system is the only one we can prove holds anything at all. So why does the runt have worlds while the sun twins stay blank? The answer turns out to be the whole story, and it is not the one anyone would guess. The joke also has a darker turn, and it is worth following before we move on, because it tells you what kind of place this is. Proxima is a red dwarf, and red dwarfs are violent in a way our calm sun is not. They flare. Proxima erupts with sudden bursts of radiation many times a day, and in 2019 astronomers caught it doing something extreme. It threw out the most powerful flare ever recorded from the star, one of the most violent ever seen from any star at all, brightening in ultraviolet light by something like 14,000 times. 14,000, a star normally far too faint for the human eye, flaring for a few seconds bright enough to be seen unaided, hurling out a wave of radiation that swept across everything orbiting it. Put yourself on the surface of that habitable zone world for the half a second it takes. There is no warning. The little red star you have always known, dim and steady, simply detonates. In the space of a single breath, the sky floods with a glare thousands of times brighter than anything it has ever thrown, and an unseen surge of radiation slams down through the air faster than anything alive could flee it. Proxima b sits so close that a flare like that does not warm the planet. It hammers it. It does not lift the atmosphere away gently over the eons. It blows pieces of it off into space in violent fits, over and over several times a day for billions of years, until whatever air the world once wrapped around itself has been beaten thin or torn down to naked rock. The one confirmed world in the liquid water zone of the nearest star is not a refuge. It is a thing being skinned alive by its own sun, on a schedule with no end. And even that, even a flayed and battered world, is more than the 2 sun-like stars have ever offered. At least the runt gave us something to grieve. The twins gave us a blank page. You might object, and you would be right to, because we did find a planet around one of those sun-like stars once. For about 2 years, nearly everyone believed it. In 2012, an astronomer named Xavier Dumusc, working with an instrument called HARPS, bolted to a telescope at La Silla, high in the Chilean desert, announced a world around Alpha Centauri b, the Orange Companion. HARPS does not photograph planets. It watches a star for the faintest wobble, the tiny rocking toward us and away again as an unseen world tugs the star back and forth, read in the almost imperceptible stretching and squeezing of the star's own light. The wobble they reported was absurdly small, a motion of barely half a meter per second, the entire star drifting toward you and away slower than a person strolling across a room, 4 light years off. From that whisper of movement they drew a planet, roughly the mass of Earth, whipping around the star once every 3¼ days. The nearest Earth mass world ever found, around a sun-like star, 4 light years from home. It ran on front pages around the world. For 2 years, it was one of the most famous planets in the sky. It was a good claim, clean, careful, from a respected team using a proven method, and it explained the data beautifully. There was only one problem with it. It was not there. When other astronomers took the same numbers and worked through them their own way, the planet began to dissolve. The signal everyone had read, as a world turned out to be an accident in how the measurements had been spaced out across time, a faint pattern in the sampling that happened to imitate the gentle tug of an orbiting planet. Run the analysis one way and the planet appeared. Run it another and it was gone. A planet that exists only when you process the data a certain way is not a planet. It is a ghost. The discovery was quietly withdrawn, and it left behind a lesson that should have unsettled people more than it did. We had not merely failed to find a world around the nearest sun-like star. We had found one that was not there, believed in it completely, and printed it on the front page. These 2 stars were not only refusing to show us their planets, they had just shown us, briefly and convincingly, a planet that did not exist. There is one more thing to understand about this system before we ask why we cannot see into it, because it turns every blank we have just described from a curiosity into something closer to an insult. We did not merely happen to know Alpha Centauri. We chose it. Of all the stars in the sky, this is the one our species decided long ago would be the first door we walked through. Look at where the human imagination has gone whenever it left Earth. A blockbuster film hung its alien moon in orbit around a gas giant in this exact system, and hundreds of millions of people have dreamed of its glowing forests without ever realizing they were dreaming about the star next door. A celebrated novel made these 3 suns the home of a civilization that decides to cross the gulf and take our world from us. Television series, video games, the whole back catalogue of stories about leaving home return again and again to the same address, until the name itself has taken on a strange domestic warmth. Like a holiday house, the family has always meant to visit and somehow never reached. And it was never only fiction. In 2016, an investor named Yuri Milner stood beside the physicist Stephen Hawking and announced a $100 million project with a single destination. They called it Starshot, and the plan was audacious to the edge of absurdity. Build a vast array of lasers on the ground, throwing something like 100 gigawatts of power up into the sky. Build spacecraft the size of a postage stamp, each trailing a mirrored sail only a few meters across, light enough that the laser beam itself could shove it forward. Fire the lasers for a few minutes, and let pure light push those tiny craft up to 1/5 of the speed of light, faster than anything human hands have ever made move, fast enough to be halfway to Mars in the time it takes to boil a kettle. At that speed, they would cross the gulf that swallows ordinary rockets for tens of thousands of years, and reach Alpha Centauri in roughly 20. Another 4 years for the images to crawl back across the light years, and we would finally see, up close, whatever circles the nearest sun. Mark Zuckerberg joined the board. The dream had money, fame, and some of the brightest minds alive behind it. And in the years since, it has quietly stalled. The Great Laser Array was never built. The sail is still a materials problem no one has solved. The fanfare faded, the urgency drained away, and the boldest plan our species has ever made to touch another star slowed to a trickle of papers and a website. We announced, with the whole world watching, that we were going to the nearest sun. And then, almost without anyone noticing, we stopped. There was no failure announced, no funeral, no moment where anyone admitted the dream was over. It simply cooled. The press releases stopped coming. The brilliant people drifted to other problems. The most ambitious thing our species ever said, out loud about reaching another star, did not collapse in some dramatic way that would at least have given it an ending. It just went quiet, the way a campfire goes quiet, until one day you notice it has been dark for a long time, and you cannot remember when the last flame went out. We had stood at the foot of the ladder, looked up at the nearest rung, named it, funded it, promised ourselves we would climb, and then we set the whole thing down and walked back inside. So this is not some distant abstraction we stumbled onto by accident. It is the place we picked, the first rung on the ladder out. The shore we have been pointing at for a century, in our stories and our science alike, the one star system in all the sky that carries the feeling of a neighbour instead of a stranger, because it is a copy of our own sun and because it is close. We wrote it into our myths. We pledged fortunes to reach it. We made it more than any other point in the dark, the answer to the oldest practical question we have, the question of where we go first, and we cannot see what is there. Of every door in the sky, we chose the one we cannot see through. So why is this one system so much harder to read than stars 1,000 times farther away? The answer is the strangest thing in the whole story so far, and once you see it, nothing about the nearest sun looks simple again. The reason we cannot see worlds around the nearest sun is not that it is too far. It is that it is too close. Everything in ordinary life teaches the opposite. Move toward a thing and it sharpens, step back and it blurs. That rule is so reliable across every moment a person has ever lived that it stops feeling like a belief and starts feeling like a law of the world. For stars, the law inverts and the reason comes down to a single idea worth holding for a moment. To find a planet by looking straight at it, you are not really looking at the planet. You are trying to pick out a faint speck, pressed up against something almost unimaginably brighter. A planet beside its own star is a candle held against a searchlight. The searchlight does not merely outshine the candle. It floods the whole field of view, scatters off every edge of the instrument, and drowns the faint thing completely. Now consider what distance does to that searchlight. The farther a star sits, the dimmer it looks. Push a sun-like star out to 100 light years, and it fades to a glow faint enough that a careful instrument can block it and hunt for the specks around it. Pull the same star closer, and it brightens until its light is screaming. Alpha Centauri A is the closest of all the sun-like stars, so it is the brightest of all, the third brightest star in the entire night sky. The quality that should have made it the easy target is exactly the quality that makes it the worst one. Its nearness, the very thing that has drawn every dream of leaving home toward this single system, is the thing that blinds us to whatever it holds. And that demands a correction, because there is a comfortable misreading of all this that has to die before we go further. It is tempting to picture the planet as hiding. Some shy world tucked behind a veil, slipping out of frame whenever we look. That is the wrong image entirely. The planet, if it is there, is not hiding. It is sitting in the open. The thing that conceals it is on our side of the 4 light years. Below a certain brightness, below a certain closeness to that screaming star, our best machine simply goes blind. Not because the world is cloaked, but because the glare wins. It is the same way a driver going straight into a low sun loses a whole stretch of road, not because the road is hidden, but because the light is in the eyes. This is not a mystery about the planet. It is a measured limit inside us. So perhaps there is a way around looking directly, and for 30 years there has been. The most successful method we have ever had for finding planets does not involve seeing them at all. It involves feeling them. A planet's gravity tugs its star very slightly back and forth as it orbits, and that small wobble shows up in the star's light. Thousands of worlds have been found this way, without anyone ever laying eyes on a single one of them. Surely then, we could simply feel for the wobble of a planet around the nearest sun. It works beautifully on lonely stars. It breaks here, on this exact system, for one reason. The 2 bright stars are not alone. They are circling each other, and the gravitational heave of one entire sun swinging around another, is thousands of times larger than the faint nudge any planet could ever give. Before you can feel the whisper of a planet, you have to perfectly subtract the roar of two stars hauling on one another. And if that subtraction is off by even a little, the leftover error looks exactly like the wobble of a planet that is not there. That is precisely what happened in 2012. The Earth mass world that filled the front pages and then dissolved was never a fraud. It was the roar of the binary, imperfectly subtracted, leaving behind a residue shaped exactly like a planet. The method that found thousands of worlds elsewhere comes to the nearest sun-like stars, and the noise of the place manufactures phantoms out of its own error. We do not just fail to feel the real planets. We feel fake ones into existence, hold the one idea again. Every method we have for finding a planet depends on the star cooperating in some way. The star has to be faint enough to block, or still enough to feel a wobble against, or lined up so the planet passes in front of it and dims it. And the nearest sun refuses all three, too bright to look at, too noisy to feel through, too unlucky in its angle to catch a crossing. Every standard tool we own, the same tools that found 6,000 worlds scattered across the galaxy, walks up to the nearest sun-like stars and stops dead. Step back from the instruments for a moment, because there is something almost philosophical hiding in this, and it is bigger than Alpha Centauri. The entire history of the telescope is a history of fighting distance. Every advance, every larger mirror, every colder detector was built to drag in the light of fainter and farther things, to push the edge of the visible outward against the dark. The whole enterprise rests on a single assumption that no one ever questions, because it has always been true. That distance is the enemy. That the close things are the easy things, already in hand, and the far things are the hard frontier. And the nearest sun quietly turns that assumption inside out. It is the close thing, and it is the hardest thing we have. It sits right beside us, the most studied, most dreamed about star system in the sky, and it defeats the very power we spent 400 years building. The frontier was never only out at the edge of what we can reach. Some of it was right next door the whole time, hidden not by distance but by nearness, and we did not even have the right kind of machine to look. If you still doubt that the trouble is nearness and brightness rather than distance, look at what we have managed everywhere else in the neighborhood, because the contrast is almost unbelievable. 40 light years away, 10 times farther than Alpha Centauri, there is a dim, cool red dwarf called TRAPPIST-1. It is so faint you could never see it by eye. And around it we have found and confirmed 7 rocky worlds, roughly the size of Earth, several of them in the habitable zone. We do not just know they are there. The James Webb Telescope has already begun reading their atmospheres, passing the star's light through their air as each planet crosses in front of it, searching for the fingerprints of gases. We are studying the weather of worlds 40 light years away, around a star most people have never heard of, in more detail than we can manage for anything orbiting the nearest sun. Come closer. 6 light years away sits Barnard's star, the next nearest star system after Alpha Centauri, another dim red dwarf. For a century, it teased astronomers with planets that turned out to be ghosts, false signals that dissolved under scrutiny, the same kind of phantoms that haunt this whole field. And then, in 2024 and 2025, it gave them up at last, 4 small rocky worlds, each less massive than Earth, confirmed. And the way they were nailed down is the point. 2 separate teams, observing from 2 different continents, one in Chile and one in Hawaii, deliberately not coordinating, precisely so that if both saw the same worlds, no one could call them phantoms. 2 independent eyes, checking each other, killing all doubt. That is what confirmation looks like when a star cooperates. It goes on. The dim red ember Proxima, as we have seen, has its worlds. Another faint red dwarf 11 light years out has a temperate world of its own. Star after star after star, all of them dim, many of them far more distant than Alpha Centauri, have surrendered their planets to us. The map of our own little corner of the galaxy is penciled full of worlds now, circling red embers near and far, around nearly every kind of star we can point at. Every kind except the one that looks like our own sun. The two nearest Sun-like stars, the near twin and its orange companion, the closest things to home in the entire sky, are the single blank space on that crowded local map. We can confirm 4 sub-Earth worlds around a troublesome red dwarf 6 light-years away, with 2 teams checking each other to be sure. And 4 light-years away, around a star that is almost our sun's reflection, we have a dot that showed up once and vanished, that we cannot pin down with the most powerful telescope ever built. The neighbor we understand least is the one most like ourselves, sitting at the one address we most wanted to read. So someone had to build a different kind of machine. Not a bigger bucket for gathering light, but a tool whose entire purpose was to kill light. To take the brightest, nearest, most blinding star and snuff it out on command, so that the faint truth standing beside it might finally show. And one of the people who built it first glimpsed what they were chasing while sitting beside a lake on a family holiday, half a world away from any telescope at all. His name is Kevin Wagner. He grew up in Kentucky and ended up at an observatory in the Arizona desert, among the dry mountains and the giant cactus, doing the kind of patient work that makes no one famous. For a few years, his particular obsession was the hardest target in the sky, the nearest sun. His group took one of the great telescopes on Earth, high in the Chilean desert, and rebuilt one of its instruments for a single job, to blot out a star and study the darkness right next to it. They gave the project a name that was also a wish: New Earths in the Alpha Centauri region. Not just any planet, a new Earth around the nearest sun. The trick they used to do it is worth pausing on, because it shows how desperate the problem really is. A star like Alpha Centauri A pours out heat. So does the desert sky above the telescope. So does the telescope itself, every warm mirror and strut glowing faintly in the infrared. To find a cool planet buried in all of that, you have to peel every other source of warmth away. So the instrument they rebuilt carried a small mirror deep inside it that could flick back and forth hundreds of times in every second, switching the view between the star and a patch of empty sky just beside it, faster than any eye could follow. Subtract one from the other, hundreds of times a second for 100 hours, and the steady glow of the sky and the machine cancels itself out, leaving only whatever is truly there next to the star. They were not so much taking a picture as scrubbing one clean, millions of times over, hunting for the single faint thing that refused to subtract away. It was neither cheap nor quick. The collaboration ran into the millions of dollars and pulled in 2 of the most serious institutions in the field. And the looking itself was an act of endurance. Beginning on a night in May of 2019, they pointed that great telescope at the same star system and held it there for about 100 hours, spread across most of a month. In that time, the instrument gathered more than 5 million images and something close to 7 terabytes of data. A mountain of pictures of one star, not a survey sweeping across thousands of targets, the way most of astronomy works, one system, one question, asked over and over for 100 hours. Is there a world around the nearest sun? Yes or no? Think about what 100 hours on a telescope like that actually costs. The great observatories of Earth are among the most fought-over instruments our species owns. Astronomers wait years for a few nights, write proposals that are rejected far more often than accepted, and measure their careers in scraps of borrowed time on the good glass. To spend 100 hours, a tenth of a year of nights, on a single star, while every other astronomer alive is competing for the same minutes, is not a casual decision, it is a bet. A wager that the nearest sun, the one target everyone assumes we already understand, is worth more than 100 other questions that could have been asked with the same time. Wagner and the people around him made that bet, rebuilt a telescope to make it, and pointed the whole apparatus at one spot in the sky, like a spear thrown at a single point in the dark. There is a particular kind of devotion in that. To build an entire machine, raise the money, rebuild a telescope, and burn 100 precious hours of the most oversubscribed glass on Earth, all for the chance at a single point of light beside a single star. Most science casts a wide net. This was a spear, aimed at one spot in the sky, thrown by people who had decided that the nearest sun was worth everything they had. and the dot did not arrive in a dramatic moment at the eyepiece. Wagner was on vacation, sitting beside a lake in South Carolina, working through the processed data remotely. The way a person checks messages on a trip, they cannot quite leave behind. The mountains were somewhere else. The telescope was on another continent. And there, on a laptop screen beside the water, he watched a point of light climb up out of the noise. A faint speck sitting in the habitable zone of Alpha Centauri A, right where a world might be. It was barely above the random static, the kind of signal that could be something or could be nothing. But it was sitting exactly where a planet ought to sit. As he later described it, there was one source in the data that looked like what a planet should look like, and that he could not explain away. He could not explain it away. He also could not prove it. 100 hours was not enough to watch the thing move, not enough to trace an orbit, not enough to be sure it was a world, and not a clump of warm dust catching starlight, or a ghost left behind by the instrument itself. So when the team published in 2021, they did the careful, honest thing. They did not announce a planet. They announced a candidate. A dot, sitting in the habitable zone of the nearest sun, that might be the closest possible world to Earth, and might be nothing at all. They wrote down exactly what they saw, marked plainly that they could not confirm it, and left it in the record for someone with a better machine to chase. A dot beside a lake, and maybe set down so carefully that no one could mistake it for a yes. And it was not the first time a human being had reached across this exact gulf, toward this exact star, and come up just short. Go back almost 200 years. In 1832, a Scottish astronomer named Thomas Henderson sat at the southern tip of Africa, at an observatory he disliked, with instruments he did not trust, and set out to measure something no one had ever managed. The distance to a star. He chose the bright point in the constellation of the Centaur, the one that drifted slightly against the fixed background of the others, because a star that drifts is usually a star that is close. The shift he was hunting is almost beyond belief in its smallness. As the Earth swings from one side of its orbit to the other, across a gap of nearly 200 million miles, a nearby star seems to lean by the tiniest fraction against the far ones behind it. And for even the closest star, that lean is barely 1 second of arc, about the width of a small coin seen from 2 miles away. That was the needle. Henderson was trying to thread by eye, night after night, with a patience that bordered on stubbornness, until the tiny shift gave up a number. And the number he got made him the first human being in history to measure the distance to another sun. The star was Alpha Centauri. He had won a race that astronomers had been losing for 200 years. And then he hesitated. He did not trust his own instruments, suspected his angles were rough, and rather than announce a result he might have to take back, he packed the measurements away and sailed home to Edinburgh, where they sat in a drawer. While they sat in that drawer, a German astronomer named Friedrich Bessel measured the wobble of a different star, a faint pair called 61 Cygni, and late in 1838, he announced it without hesitation. He took the title Henderson had earned first, and he took it by about 2 months. By the time Henderson finally published, he was second. History remembers the one who spoke and forgets the one who waited. There is something almost unbearably human in that hesitation. He had the answer in his hands, the answer men had chased for 200 years, the first true measure of the distance to another sun, and he could not quite trust it. He turned it over, doubted his instruments, doubted himself, and chose silence over a claim he might have to take back, and the silence cost him the one thing the work was worth. He was not wrong to be careful. Care is how science protects itself from its own enthusiasm. But care, taken far enough, becomes its own kind of failure, and Henderson lived the rest of his life as the man who had been first and said nothing. And his distance, when it came, was a little short. He had placed Alpha Centauri at about 3¼ light years. The true figure is closer to 4⅓, a quarter farther than he believed. He had reached across the dark and touched the nearest sun to our own, with nothing but arithmetic, and even then he had not quite reached it, missing the distance by a quarter, and the credit by 2 months. Set the two men side by side across the 2 centuries between them. Henderson, with a notebook and a telescope, measuring how far the star was and dying without ever learning what circled it. Wagner, with a machine built to kill light and a lake at his back, finding a dot he could see but could not swear to. The same star, the same reaching across 4 light years, the same instinct buried so deep in us that a Scottish lawyer felt it in 1832 and an Arizona astronomer felt it on a family holiday in 2019. The pull toward the nearest sun and the need to know what is there. And the same ending 200 years apart. We reach, we get close, we come up just short. Between those two men lies almost the entire history of modern astronomy, every advance in glass and metal and computing. And at the far end of all of it, we are standing more or less exactly where Henderson stood. Knowing the nearest sun is there, knowing roughly how far, unable to say what moves around it. But Wagner's dot did one thing Henderson's number never could. It gave the next machine somewhere to aim. After that dot, searching the nearest sun no longer meant sweeping a wide blank field around a blinding star. There was a mark on the map now, a particular spot where, beside a lake, something had briefly risen out of the noise. So when the most powerful telescope ever built was finally ready to try, it did not have to guess where to look. In August of 2024, it turned toward the nearest sun, toward the exact place a man had marked from his holiday, blocked the searchlight, and looked. The telescope is called James Webb, and it does not see the way human eyes see. Your eyes catch visible light, the kind the sun pours out in floods. Webb catches infrared, heat light, the faint glow that warm things give off in the dark. That difference matters more than it sounds. In visible light, a planet beside its star is hopeless, outshone by a factor of billions. In heat light, the gap narrows to mere thousands, because a warm planet glows on its own terms rather than only by reflecting its star. Still desperately hard, no longer impossible. It helps to picture the machine we are talking about. James Webb is a telescope roughly the size of a tennis court, its main mirror a single sweep more than 6 meters across, built from 18 gold-coated segments locked into one golden honeycomb, and it sits about 1 million miles from Earth, at a quiet point in space where it can stare into the dark, without the Earth or the sun ever swinging across its view. The part of it that matters here is a camera tuned to the mid-infrared, fitted with a coronagraph, a small mask, designed to sit directly over a star and choke off its light, working at a wavelength near 15 microns, deep in the heat band, where a cold world stands out best against the star it circles. It is, by any measure, the most capable eye our species has ever lifted off the ground. And this is the instrument that found the dot, and then could not find it again. So Webb slid a mask across the face of Alpha Centauri A. The star was so bright that the telescope's own guidance system could not lock onto it without being overwhelmed, so the team had to aim at a dimmer star off to the side, lock on there, and then slew across to where the bright one should be, dropping it behind the mask almost by dead reckoning. It is the equivalent of parking a car in a spot you cannot see, using only the memory of a landmark you touched a moment before. They managed it. And then, because there are 2 bright stars here, and a mask can only block one, they built a model of the second star's glare and subtracted it as well, peeling the image apart layer by layer, lifting away one sun and then the other, until only the faint background was left. In that stripped-down darkness, where both suns had been erased, a point of light was sitting, more than 10,000 times dimmer than the star it circled. If Alpha Centauri A were a stadium roaring with 10,000 voices, this was a single person whispering in the very back row, and the team had caught the whisper. It sat about twice as far from its star as the Earth sits from the sun, out in the warm zone. From its brightness and its heat, they could sketch a rough portrait, a giant, something close to the mass of Saturn, at a temperature around 225 Kelvin, cold by the standards of a human body, warm, for the empty dark between stars, stand out there for a moment. Twice the Earth's sun distanced from a star almost exactly like our own, there may be a world the size of Saturn, turning slowly through the same kind of gentle warmth that falls on us. From its cloud tops, the nearest sun would hang in the sky as a brilliant yellow point, Far smaller than our sun looks to us, but unmistakably the same kind of star. And somewhere off in that same sky, 4 light years away, a pale dot that an astronomer there might never be able to resolve would be the sun that warms you now. For one image, in August of 2024, that world was real. The thing Henderson never met. The dot Wagner could not confirm, finally caught by the most powerful eye ever built, sitting exactly where it had been promised to be. And consider for a moment everything that had to happen for that single faint point to surface at all, because it tells you how thin the thread really was. The star had to be hidden behind a mask placed by Dead Reckoning, dropped into position by a telescope that could not even look at it directly without going blind. The second star blazing nearby had to be modelled and erased, its glare reconstructed and stripped away by software. Stray light bending around the edges of the mask, scattering off the struts and mirrors of the instrument itself, had to be peeled back layer after layer, because each of those artifacts can throw up a false spark that looks exactly like a planet. What was left, after all of that subtraction, was a picture that is less a photograph than a sculpture carved out of noise. And in that carved out dark, 10,000 times below the star that had filled the frame, one point of light remained standing where the others fell away. The whole achievement is balanced on the knife edge between a real world and a trick of the light, and the people who found it knew it, which is exactly why they refused to call it more than a candidate. But let yourself believe it, just for a breath, and stand on it. A world the size of Saturn, out where the warmth is gentle, under a sky with a single brilliant yellow star. There would be no solid ground to stand on, only the slow churn of a giant's clouds, and a cold that would kill anything from Earth in an instant. But the light falling on those cloud tops would be the light of a star that is, for all purposes that matter, our own sun's reflection. The same colour, the same kind of fire. If anything were ever to drift in that sky and look outward on a clear night, it might pick out, among its own stars, one faint unremarkable point that happened to be the sun, and never guess that a warm blue world was circling it, with oceans and weather and someone looking back. Then they looked again and it was gone. A single image is never enough for a claim this large, so the team secured more time and pointed Webb back at the star in February of 2025. They searched the warm zone where the whisper had been. Nothing. They tried a third time in April. Nothing again. The point of light that had been so clearly present in August had vanished and stayed vanished across 2 more attempts. One of the astronomers, a young researcher named Aniket Sanghi, put it in the plainest words anyone could. They were facing, he said, the case of a disappearing planet. We finally glimpsed something around the nearest sun, the thing we have wanted for a century, and the instant we turn back to confirm it, it is not there, seen once, lost twice. It has the exact shape of the 2012 ghost all over again. A flicker that meant nothing. A hope that dissolves the moment it is tested. That is the easy reading. A blip that failed to repeat, probably never real. It is a good reading. It explains everything, except for what the orbits do to it. Because the team did not simply shrug and file the dot away, they asked a sharper question. If that point of light was a real planet on a real orbit, where would it have been in February and in April? A planet does not hold still. On a tilted, stretched orbit it spends part of its time swung wide of the star, out where the mask can reveal it, and part of its time swung in close, lost in the very glare the mask cannot kill. So they simulated it. Millions of possible orbits, every one of them consistent with that single August sighting, and for each one they asked the same thing. During those 2 follow-up windows, would the planet have been far enough from the star to see, or hidden inside the glare? The answer lands like a hand on the back of the neck. In more than half of those orbits, 52% of them, the planet would have swung too close to the star during both windows to be visible at all. Not gone, just temporarily drowned in the searchlight, exactly when we happened to look. The 2 disappearances were not evidence that the planet was fake. They were exactly what you would expect if the planet were real, and simply caught on the wrong stretch of its path each time we checked. So the easy escape closes. You cannot say it vanished, because it was never there, because a real world on a perfectly plausible orbit would have vanished in precisely the same way, at precisely those times. There is one escape left, and it is the one that keeps serious people awake at night. Perhaps it is not a planet at all, perhaps it is dust. A clump of warm debris orbiting the star, glowing faintly in the infrared, bright enough to mimic a world for a single image, and then drifting, spreading, fading below detection. Dust would explain a thing that appears once, and never repeats just as neatly as a planet caught in glare. And telling a planet from a clump of dust in one faint smudge of heat is genuinely, brutally hard. But there is a single difference between them, and it is the whole game. A planet obeys orbital mechanics. It returns, it keeps an appointment, dust does not. It dissipates and reshapes and shows up nowhere in particular. So the team fed everything into the orbits, the August sighting, the 2 disappearances, and Wagner's dot from 5 years earlier, and asked the only question that can settle it. If this is a planet, when should it swing back into view? The answer was a date, August of 2026. A planet will keep that appointment, dust will not. And it is worth being precise about what that returning dot would actually be, if it keeps the appointment, because almost everyone misses how strange it is. Start with its orbit, which should not exist. The simulations that keep the candidate alive do not describe a tidy circle. They describe a stretched, lopsided ellipse, swinging the planet from roughly the Earth's distance at its closest to about twice that at its farthest, and tilted at a steep angle to the plane in which the 2 stars orbit each other. Both of those features are problems. In a system with a second sun heaving past every 80 years, the companion's gravity should, over the long ages, grab a planet on a tilted eccentric path and slowly wind it up, pumping the stretch of its orbit higher and higher, until the world is either flung out of the system entirely or dropped into its star. A giant planet riding exactly that kind of orbit, and surviving there for billions of years anyway, is not what our models of how planets form and endure would predict. It sits right at the edge of where anything should be able to last. If it is real, it is breaking a rule we were fairly sure of, using the first clear example we have ever had to check the rule against. Now stand it next to every other world we have ever directly photographed, because the comparison is staggering. Almost every planet we have managed to image directly actually capture as a point of light rather than infer from a wobble or a shadow has been a monster. Young, scorching super Jupiters, many times the mass of our largest planet, glowing white hot with the leftover heat of their birth, orbiting far out from their stars where the glare is weak and the spacing is generous. Those are the only planets bright enough and far enough from their suns to catch. This candidate is none of those things. It would be the coldest world ever directly imaged, a couple of 100 degrees instead of over 1,000. Among the lowest in mass, a Saturn rather than a swollen super Jupiter. The closest to its star, tucked into the warm zone rather than flung to the frozen edge. And the nearest to Earth by far, 4 light years out instead of dozens or hundreds. Any one of those would make it a landmark. Holding all 4 at once would make it the most important direct image of a planet ever taken, the first time we had ever seen with our own instruments, a giant world sitting in the habitable zone of a star like our sun. That is the prize hanging on a dot that has shown up once in 3 tries. A world that should not survive where it sits, that would rewrite the record books the instant it was confirmed, that may be turning quietly through the warm light of the nearest sun right now, 4 light years away, or may never have existed at all. So that is where we stand. Not with an answer, with a fork and a date. And the quiet question we set down at the very beginning is still ticking underneath all of it. If we cannot hold even this one giant steadily in our sight, what does that say about everything else we claim to see? Now turn the telescope around. Everything so far has pointed outward, from us toward them. But the difficulty in this story was never really about Alpha Centauri in particular. It is about the act of seeing across 4 light years, and that act does not care which direction it runs. So point it back the other way. Put an astronomer on a world circling Alpha Centauri A. Give them our exact technology, the same telescope, the same mask, the same 100 hours of patience. Let them turn it toward the faint yellow star they call their nearest neighbor, the one we call the sun. What would they see? You already know, because we built the answer a few minutes ago. Below a certain brightness, the glare wins every time in every direction. Their telescope, like ours, would go blind to anything too faint, sitting too close to that screaming star. They would catch Jupiter, maybe. They might, on a good day, catch a hint of Saturn at the ragged edge of the possible. And then nothing. Everything else in our solar system would fall below their floor, lost in exactly the way the worlds of Alpha Centauri are lost to us. They would not see Mars, they would not see Venus, they would not see Mercury, and they would not see Earth. This planet, the one under your feet right now, with its oceans and its weather, and its 4 billion years of unbroken life, the only place we know of anywhere that holds a living world, would be invisible to them, too small, too dim, too close to the glare of its star. An astronomer at the nearest sun, using the finest machine we know how to build, would look straight at our home and see a blank patch of light where it ought to be. They would not know we are here, they could not know. We are not the watchers in this story, gazing out from a safe seat at the cosmos. We are also the dot, the faint, close, drowned-out speck that a neighbor 4 light years away would stare straight through, without ever suspecting a world was there, let alone a living one, let alone us make it concrete. Suppose right now, on a world circling the nearest sun, an astronomer points an instrument as good as ours back at the pale star we live beside, and runs the same painstaking process. They block the glare. They peel away the scattered light. They search the warm zone. And what do they write down at the end of it? 1 line, 1 gas giant detected, possibly a second. No other planets found. That is the entry. That is the whole of what our solar system would be to them. Not Earth, not the oceans that cover most of it. Not 4 billion years of life, clawing its way from single cells to cities. Not a single one of the roughly 8 billion people breathing on it tonight. A blank, where the most important planet we know of in the entire universe actually sits. Would they wonder about us? They could not. We would not register as maybe the way the giant registers for them. We would not even rise to the level of a question. We would simply be absent, filed under nothing. A quiet gap between 2 lines of glare in someone else's catalogue. The one place we are certain holds life would be to the nearest possible observer, indistinguishable from empty space. And that cuts both ways. Every time we look out and see nothing, and take the nothing for an answer, we are doing exactly what they would do, looking back at us, and being exactly as wrong. And the story now balances on 2 endings. Neither of them are relief. If the dot is real, it is the giant that should not survive where it sits, and confirming it would mean tearing up what we thought we knew about how worlds endure. If it is nothing, only dust and instrument ghosts, then the most powerful telescope ever built stared point blank at the nearest copy of our own sun, and still could not say whether anything is there. One ending rewrites the rulebook. The other tells us our sharpest eyes go blind exactly where they should see best. Not a failure of distance, a failure at arm's length. We do not know which. Every measurement we make sharpens the question. None of them closes it. But there is a date now, and it is not far off. If the dot is a planet on the orbit the models favour, it should swing back into view in August of 2026. So Webb will look again. And it will not be looking alone, because in that very same month, a second machine leaves the ground. The Nancy Grace Roman Space Telescope, carrying a coronagraph far better at suppressing a star's glare than anything we have ever flown. Built from the start to photograph giant planets around sun-like stars, is set to launch at the end of August 2026. 2 eyes, in a single month, turning toward the same star, asking the same question. Henderson asked with a notebook, and Wagner asked from beside a lake, is there a world there? Think about how rare that convergence is. For almost 200 years, the question has been asked 1 instrument at a time, each one falling just short, each answer and maybe handed forward to the next generation of glass. And now, in a single month, Two of the most powerful machines our species has ever made will both be aimed at the foot of the Centaur, one in space and one just leaving the ground, either of them capable of settling it. If the dot is real and keeps its appointment, this could be the month that maybe finally becomes a yes, the month we stop guessing about the nearest sun and simply see. And if it does not return, if Webb searches the warm zone and finds only clean empty dark where the orbit said a planet should be, then the dust answer rises, the candidate weakens, and the nearest sun keeps its oldest secret a while longer. 1 month, 2 eyes, a coin that has been spinning since 1832, finally coming down. And those two are only the first of a whole generation of eyes now being built to fight this exact problem. The Roman telescope carries a coronagraph so advanced it can pick out a planet 100 million times fainter than its star, something like 100 to 1,000 times better than anything we have ever flown, built specifically to photograph giant worlds around sun-like stars. On the ground, telescopes with mirrors more than 30 meters across, the largest ever attempted, are rising in the deserts of Chile and on a Hawaiian peak, each one a light bucket vast enough to resolve detail no existing instrument can reach. And further out, still on the drawing board, sits the boldest of all, a future flagship designed for one purpose above every other, to take the direct image of an Earth-like world around a sun-like star and read its air for the signatures of life. The eyes are coming. They are better than anything we have. Some of them will see things at Alpha Centauri that Webb cannot. But the cruelty buried in that hope does not go away, no matter how good the glass gets. Every one of those machines, the orbiting coronagraph, the giant mirrors, the flagship still decades from launch, will arrive at the nearest sun and meet the same wall the first ones met. The star will still be the brightest of its kind in the sky. There will still be two of them, blazing side by side, glare layered on glare. The nearness that defeats us is not a flaw in the instrument that a sharper instrument can fix. It is a property of the place. Better eyes will push the flaw lower. They will catch fainter worlds, refine the orbit of the vanishing dot, perhaps even confirm it at last, but the smallest worlds, the rocky ones, the warm wet ones, where something might be living, will stay below the flaw at the nearest sun, just as they stay below the flaw at every sun. We are not one telescope away from seeing them. We may be no telescope away from it at all. There is even a slower clock running underneath, one that almost no one outside the field ever hears ticking. The two bright stars circle each other, and as they do, their apparent gap in our sky slowly opens and closes across that 80-year orbit. For long stretches, they sit so close together on the sky that their glare merges into one hopeless smear, and no mask can separate them cleanly. Right now, they are far enough apart to give us room to work. This is the open window, the good years. And it is already beginning to close again, decade by decade, on a cycle longer than most careers. Miss it, and the next equally favourable chance lies on the far side of a wait that will outlast many of the people now staring at the data. So everything converges on this narrow window. And now consider what actually hangs on it, because it is far larger than one disputed dot beside one star. We say the galaxy is full of worlds like ours. We say it almost as a comfort, a thing to reach for on a clear night. From a telescope that surveyed tens of thousands of distant stars, we worked out that roughly 1 in 5 stars like our sun should carry a rocky world somewhere in its habitable zone. Run that fraction across the whole galaxy, and the number that comes back is staggering. Billions of potential Earths, scattered through the dark, surely some of them alive. Surely we are not alone. We repeat it so often that it has stopped sounding like a guess and started sounding like a fact about the universe. But look at what that number is actually built on. Every one of those worlds was counted by inference, never by sight. From the wobble of a star or the faint regular dimming of its light, the same families of methods that we just watched fail completely at the nearest test case. We have never once pointed a telescope at an Earth-sized world around a sun-like star and simply seen it. Not anywhere, not yet. The billions are an estimate, a confident shape sketched around a hole in our vision. And the single closest place we could actually check that estimate at close range, the nearest copy of our own sun, just handed us a flickering dot we cannot even confirm is a planet. Think about what it would genuinely take to be sure the galaxy is full of life. You would have to be able to see the life, to see the worlds it lives on, to pick a small rocky planet out of the blinding glare of its star and study its air. And we cannot do that for the nearest sun. We cannot even confirm a giant the size of Saturn there. The small worlds, the rocky ones, the ones that could be warm and wet and breathing, sit far below the floor of what we can detect, invisible not only at Alpha Centauri, but at every sun in the sky. The exact worlds that would answer the question of whether we are alone are precisely the worlds we cannot see anywhere at all. That is the real disappearance in this story. Not a dot in an image from one August night. What vanishes, the longer you look, is the certainty we thought we had. The quiet confidence that we more or less know what is out there. It goes the instant you look closely at the nearest sun and understand that we cannot see what circles it, that we ourselves are a dot, drowned in our own star's glare, invisible to any neighbour who might at this moment be looking back. Almost 200 years ago, a careful, doubting man at the southern tip of Africa measured how far away this star was, and died without ever knowing what moved on the other side of that distance. We have not done very much better. Every larger mirror since, every colder instrument, every machine flung out to 1,000,000 miles from Earth, all of it aimed at the nearest sun, and we still cannot say what circles it. He measured the distance and never met the star. We have spent 2 centuries trying to meet it, and it has answered us with a flicker and a vanishing. And we have already given the thing a name. The star itself has carried one far longer than almost any star in the sky. Rigel Centaurus, the foot of the Centaur, named by people who never knew what a star was, the way you name a thing you intend to keep. And now, circling that ancient foot, there is a maybe. A dot seen once and lost twice. That might be a Saturn-sized world riding an impossible orbit, or might be a smear of dust, or might be nothing at all. A phantom, our finest instrument, coughed up at the very limit of its sight. We cannot confirm that it exists, and we have named it anyway. Rigel Centaurus b. We have given a name to a thing we're not sure is there, around a star we have known since before history, 4 light years from the chair you are sitting in. That is either the most hopeful thing our species does, or the most haunted. And it may be that those are the same thing. So here is the question that has been waiting underneath all of it, finally turned around to face you. If the most powerful eye ever built cannot find a giant around the nearest sun, and the same eye turned the other way would never once find the Earth, then strip the comfort away and look at what is actually left. Either the dark next door is crowded with worlds we cannot see, oceans and weather, and perhaps living things that are right there, 4 light years away, and that we will never lay eyes on. Or it is empty, and we are as alone as it is possible to be, a single lit window in a house with no other rooms. Both of those are consistent with the data we have right now. Both fit every measurement, we cannot tell which. Not now, perhaps not ever, with eyes that go blind at the one distance where they ought to see most clearly of all. We will live and die without knowing whether we were surrounded or abandoned. So will the people who come after us, and the people who come after them, each generation looking up at the same calm point of light, unable to say whether it is a neighbour's window or the last campfire in an empty country. That is the sentence the nearest sun hands down to us. Not danger, something quieter and far harder to carry. A permanent not knowing about the only question that has ever truly mattered, written across every generation that will ever look up. And do not lose the wonder in all of this, because it is real and it is enormous. We are a species that measured the distance to another sun with nothing but angles and patience before we could fly. That taught itself to switch off the brightest star of its kind on purpose and lift from the glare beside it a whisper 10,000 times fainter, and from that whisper alone weigh a world and take its temperature across 4 light years of empty dark. Henderson strained for years just to learn how far this star was. We are now close enough to stand here and argue about the weather on something that may be circling it. The reaching that began with a notebook at the Cape of Good Hope has become a machine 1,000,000 miles above the Earth, and it has very nearly closed its hand on the thing it was reaching for. We are not failing here. We are standing at the farthest edge anyone has ever reached, looking harder than anyone has ever looked, and very nearly seeing. So here is the one thing worth doing. When you can, go far enough south on a clear night until the bottom of the sky opens up below the familiar stars. Find the Centaur low against the horizon and the bright point at its foot. It will look exactly as it always has. Calm, steady, unremarkable, the kind of star you would walk straight past without a second glance, the way our species walked past it for thousands of years. But you are different now, because you know what is sitting there inside the glare. A near twin of our own sun, with a maybe world turning slowly through its warm zone, named and unconfirmed, seen once and still waiting. You know we have stared at it with the finest instruments we will ever build, and still cannot tell you what moves around it. And you know the colder thing as well. That from out there, our own sun is just another quiet point of light, and the Earth, with everything on it, with everyone who has ever lived on it, with you standing on it tonight, does not show up at all. You will never look at that star the same way again. And the next time someone tells you, with easy confidence, that the galaxy must be full of worlds like ours, that we surely cannot be alone, you will know exactly what that sentence is made of. Not a count, a hope, a confident shape drawn around the size of what we cannot see. The nearest sun showed us the edge of that hole, and it is large enough to hide an Earth in. 4 light years away, 100 light years away. Everywhere we have ever pointed and seen nothing at all. We named a ghost around the nearest star, and we are still waiting to learn whether it was ever there. That is not a failure. That is what it looks like to stand at the exact edge of what we can know, on a small bright dot that no one else can see, and reach out into the dark anyway. The silence we keep mistaking for emptiness was only ever the glare, and somewhere inside it, 4 light years away, a single point of light is either a world, turning quietly through the warmth of the nearest sun, or nothing at all. And it is waiting in August to tell us which.